Good? Okay.
Well done, Pat.
Alright.
That one, no.
Diffusion is the driving force behind the movement. You guys got this? Diffusion is a driving force behind many substances as they move across the cell membrane. All it takes is for there to be a different amount of concentration inside the cell and outside the cell. That's all it takes. Okay? What does diffusion have to do with the cell membrane? Well, suppose a substance is present in unequal concentrations. Okay? And that's what they're showing you here. Inside the cell, not so much. Outside the cell, you got lots and lots. So there's a higher concentration of the solute on one side of the membrane than on the other side. Diffusion causes a net movement of particles from the area of higher concentration to the area of lower concentration. So you start moving them across the membrane. Okay, eventually they balance out. They reach what we call equilibrium. It's an equal amount inside the cell and outside the cell. Okay? And then they maintain that equilibrium. Okay? They may continue to exchange particles, but that balance stays the same. Remember, I've told you many, many times, nature hates for things to be unbalanced. Nature wants everything to be balanced, whether it's in an ecosystem, okay, whether you have a lot of predators and not too many prey, okay, or whether you are working in with a cell in concentrations of solute inside the cell and outside the cell. Nature hates things to be unbalanced. Nature wants those to come back into balance and try to be level as much as possible, or equal as much as possible. We'll reach that equilibrium. Okay? So, it says,
Now I smell.
You get it?
Okay. I can smell from over here.
Even when, okay, so even when the equilibrium is weak, or even when the equilibrium is reached, the particles of solution continue to move back and forth. Okay? They continue to move back and forth. However, because almost equal numbers of particles move in each direction, there's no further net change. It doesn't change. The amount inside the cell and the amount outside the cell have reached equilibrium, and they continue to exchange back and forth, but now it's balanced. And they've reached that balance. Okay. All right. So that's diffusion. All right. That's diffusion. And eventually, the spray will be evenly distributed throughout the room. So this diffusion, this form of diffusion occurs without any help. Okay? This form of diffusion occurs without any help. That's why we call it, that's why it's one of the forms of passive transport. Okay? It doesn't require any energy. It does this all by itself. Okay? This is a form of passive transport. It doesn't require any energy. Talk a little bit about facilitated diffusion. Okay, well, it's still diffusion, all right, but now it's facilitated. Well, what does facilitate mean? What does it mean to facilitate? What does the word facilitate mean?
I know what facilitate.
What does facilitate mean? Facilitate means to make it easy. Okay? So if you're a facilitator, you're going to help make something easy. That's your job. You're going to help make things easier. Okay? Okay? Okay. So if we take that word facilitate and we add it to the word diffusion, what does that mean for diffusion? What does that mean for diffusion?
It makes diffusion easier.
It's going to make diffusion easier. It's a form of diffusion that is going to be facilitated. Somehow it's going to get some help. All right. So facilitated diffusion, a type of diffusion that needs some help. It needs a little bit of help, okay, to make it easier. Since cell membranes are built around a lipid bilayer, the molecules that pass through them are almost easily or small and uncharged. Uncharged? What do you mean we are uncharged?
No electron.
Oh, good. Thank you. Excellent. Excellent. Good job, Dwayne. There's no charge, there's no electrical charge on these particles as they're moving across the membrane. That's important. That's really important. That's a good point. Okay, these properties allow them to dissolve in membranes in a lipid environment from many ions like chlorine and large molecules like sugar or glucose, they seem to pass through the cell membranes more quickly than they should. It's almost as if they figured out a shortcut across the membrane. How does that happen? Okay, how does, oh look, they asked the same thing. How does this happen?
I don't know.
How does this happen? Okay. There are proteins in the cell membrane that act as carriers or channels, making it easier for certain molecules to cross. Red blood cells, for example, have protein carriers that allow glucose to pass over the cell membrane. Okay? And it allows them to go in either direction. Only glucose can pass through these protein carriers. Okay? So let's get back to our bilipid image and see if they have that. Let's see if they show that. Oh, look there, membrane proteins, right there. That channel. Okay? If something is moving through this channel, okay, whatever it might be, if something is moving through this channel, then it's being facilitated. It's getting help. And it's making it easier for this particle out here to get across that membrane and get inside the cell. Okay? That's facilitated diffusion. Okay? That's facilitated diffusion. This process, in which molecules that cannot directly diffuse across the membrane pass through those special protein channels, okay? And that's known as facilitated diffusion. They have to go through those channels. That's the only way they get into the cell. Hundreds of different proteins have been found that allow particle substances to cross membranes. Although facilitated diffusion is fast and specific, it is still diffusion. So it does not require any additional use of any energy. All right? So that's why it's still called diffusion. Because again, diffusion doesn't require any energy. These are passive transport. Diffusion, facilitated diffusion, those are forms of passive transport. Okay?